building a two-dimensional little game, 2D game in Flutter, and it is meant to support multiplayers. So let's just create a tag here. So this is episode 8. We'll start like this. It is the same as episode 7 end, but that's fine. Now, we basically were in the middle of building the thrust sprite. We were able to, pull the SpriteSheet, and what we basically want to do now is we just want to add a render method here for now, right? And obviously the render method will have to take a canvas, and now the question is, who's responsible for figuring out where to render this? So maybe what we need to do is, if we want this guy to be responsible, we give it the player center and we give it the player width. So now, right now you could say, well, okay, well these should actually be this. Those one, well, the player center changes. The player width most likely will not change during the game, but maybe it will, right? We said like maybe the player wants to, we wanted to maybe, I don't know, when it's exploding or something, we want it to grow bigger. So if you have that information, right? And I mentioned before, so actually what I want to do is I'm going to go into the build, to our build here. Basically, when we're building the model, we were setting the angle to something like other than 0. So we're setting it to pi divided by 2, which we don't want anymore. So now if we re-render, restart it, now our player should be, this is the original position. That's how we should think about this too. So when we render this, we want to basically take the center. So basically the center that we want to render it is basically the player center minus the player width, right, for the x-axis. So basically it would be an offset of player center dot x minus the player width, and the y center would be exactly the same as the player center. So they basically keep that the same. Center dot I think it's dy. We could have also translated it, but it's fine like that. So this is actually, to me, looks clearer. So we create a new center, which basically just move to the left. And as I said before, if we happen to be rotated, okay, no, it doesn't want to rotate anymore. No, that's interesting. If it wants to rotate, right? Now we don't have to take that into account anymore because we already have the canvas rotated. We can treat it as if the player is like that. So we don't have to think about that at this point. But we will maybe have, well, not maybe, but I know we will have to actually rotate the thrust itself because it's pointing upwards versus it needs to be pointing to the right, right? But for now, what we'll do, we just take any sprite, right? Take the first sprite, get index, or let's just get one in the middle, because as you can see, the first one is kind of hard to see because it's almost empty. So we'll get some from the middle, and so we get the sprite, and then we can render it, the canvas, the center, right? And then we have to decide how big we want to render it. So when we don't give it the width and the height, well, it's required, so we need to give it that. So the thrust sprite, we actually will need to give it the width and the height here. So final double width and height. Okay, and So for now, let's give it something so we can actually get going here. But we'll definitely well, make this required. This required definitely. Well, it will be required. We'll for now we'll keep going like this. So we give it the width is the width, and then height. Okay. So we render it, and so right now we don't rotate it. So basically, what should happen is now in our game, our actual game, when we render the player now needs to also render its thrust. So if the player applied thrust, then we render the thrust. So we have the thrust sprite here, and we give the canvas. We give it the player location is actually offset 0, right, from where we are on the canvas, and then we have the basically the player width. So the player width we say is the tile size for now, right? Okay. So we got that. And so now let's see what happens. So now we should actually see something rendering. Okay, cool. So there's some problem with this, but it is rotating with us. So that's an interesting development. So we're gonna have to see what we're doing wrong here. So we have the player width. First of all, it should probably not be player width entirely. It should be divided by 2. So now it should be closer now. Okay, so we got some real interesting problems here. Got some real interesting problems here. So basically, oh, we already translated. So we tried to already do it the right way, but we don't want to do it yet. So now we are where we want to be. So and actually, this canvas translating has to happen here. So basically what I wanted to get is we can see now that the thrust is pointing in the wrong way. So that means we cannot just easily just render it where we want it to render. We actually need to rotate. Again, for this, we need to actually go to the center of this, wherever we want to render it, and then we need to rotate, and then we actually need to render it at offset 0, like we did with the player. So what we want to do is we want to translate. So we calculate the center, and then we actually translate this to the center dot x and center y. Before we do that, though, we save the canvas, right? Because we might be rendering multiple things on the player. So we translate, and then we render. But basically, instead of now, since we already translated, we're going to render at 0, because now we're already at the point where we want it to be. So now if I refresh, it should be the exact same thing. Okay, good. So now what we can do, we can rotate the canvas by, we need to rotate this basically to the left about 90 degrees, which should be about pi divided by 2. So let's see now. It didn't do anything. Okay, it did. There you go. So now we basically got this in the right position, right? So we're rendering the sprite at least in the right position. We just basically have one sprite. So basically, we're not having animation. We just show one sprite. So that would already be almost sufficient, but we want to add the animation as well. So player width divided by 2. That seems to be just about right. We want to maybe actually leave it there for now. Now what we also want, we actually want to make this required. We want to pass this in. Don't want to hard code this. And it will most likely be the tile size divided by 2. So game props. So basically, we just do the time size here. So we have the width, which is the tile size, and the height. We also do the tile size. All right. Now nothing should have changed. Okay. Okay. So it did. Interesting. So 20 is not the tile size apparently. So let's see what our tile size is actually. Our tile size is 40. So I'm not sure. Oh, we were doing it by divided by 2, right? So let's do that again. We had 20, so we divide by 2. Okay, now we have it back to where we want it, how we want it, right? Now, obviously, this could also be a constant somewhere, but this is fine for now. So we're basically telling it tile size by 2, create the thrust sprite. And now basically we're rendering it in the same space. Now let's see if when we rotate, still right. Okay, perfect, right? So now let's just check that in. So we had thrust rendering in correct position, rotated. Okay, so now what we can do is we apply the animation, right? So instead of getting the index, we want to get current, right? So the thing is that I said that I want to basically do the animation here, right? Now, flame includes an animation. So let's pull that over here and let's look at what they actually do here for animation. So there's an animation here. So they have frames, clock, elapse, loop. So it's frames sequenced, step time. It looks very complicated, all of it. So you can see that they actually, they first put the sprites in two-dimensional, maybe two-dimensional thing, and then they try to make it one-dimensional or something like that. But it's actually fairly simple. All we actually need to do is increase an index, right? Like they do here. And so basically what they do is like here they take how long should the animation take overall, how much is actually elapsed, and then they basically step. So you calculate the step time, like when to go to the next index. So basically that's all that is. And we're actually going to hard code that in here for now. And then we'll pull out the animation, or maybe let's call it SpriteSheet. We're going to pull it in here. Right, so basically what we're going to do. So we're going to need a SpriteSheet. Right? And then we're going to have a getter which basically gets the so then we have so what I'm going to do is I'm going to create that as part of the engine. SpriteSheet. We may need other animations, but if we ever find that there's a bunch of repetitive things, because animations have certain things in common, we'll pull that out later. But for now, let's not overcomplicate things. So here we got the SpriteSheet animation, and then we'll put that over here to make sure that we understand how this would be used. So we get the SpriteSheet animation over here. Okay, so we need a SpriteSheet, and we need the sprite. We import it, and then basically we say, so the index, so we need an int current index, and no one should actually have to know this except us. And so we say that's basically our SpriteSheet dot get index current index, right? So that's how we get the current sprite. And so instead of calling it current sprite, we just call it sprite. And then here we need to so what we need one other thing. We need basically double duration in milliseconds. We could obviously do a duration like a dart class duration, but I think it's easier that way. Have everything in milliseconds here. And then what else do we need? So we have the sprite. So we should be able to calculate everything from there. And so basically all we do is now. So first of all, let's create this. So we have SpriteSheet, and we tell it how long should the animation last. Oh, and then basically we say final bool loop. Okay, and so we also need to loop. Actually, in order to do this, we just so so we say this dot loop, and by default it's false. Okay, so basically once the animation completes, it's done. Okay, so then when we do an update, right here basically we need to calculate what index are we in, right? So so we need to basically, when we create the sprite sheet, and if we have no start yet, so yeah, so basically we have the entire duration. So what we need to do, we need to have a double start time, right? Start timestamp. So if start timestamp null, then we say start timestamp is basically, no, you know what? No, we don't need the start. We need, okay, let's we think a little bit. So we got the duration, right? So, right. So basically, what we actually need is we need to say how much has passed so far. Delta, right? They call it clock. Let's call it the clock. So the clock starts at 0, right? Okay. So now what we'll do is we say the clock is delta t, right? And so then we say, well, we know what the duration is, right? So now we know how many sprites we have. So how many basically we need to figure out like when do we get which sprite, right? So maybe when we need to calculate this, we just say time per sprite, right? So double milliseconds per frame, right? Right. So let's just say frame milliseconds. Okay. So then we say, okay, frame milliseconds is the sprite sheet that we have dot length. Okay. So basically, we are not allowed. We need to get the length. We need to be able to get the frames. So we're going to get a getter, so int frame count. And that's basically just going to be the length of the sprites. Okay. So then we basically say the frames MS is sprite sheet of frames count, right? And we divide that into the duration ms. So now we know each. Okay, why is this not happy? Yes, it's there. Oh, yeah, okay. So okay. So now we know how long each frame is. So we say then the clock is something, and then basically the frame index then, right? That's going to be the current index, right? We can set that here. The current index is how much time has passed, which is basically clock, right? That's been ticking, divided by the frame per second, right? Except now we have a problem because this needs to be an integer. So we need to convert that somehow to an integer, and we can floor it or we can route it. It's probably easier to just floor it. Okay, so let's see. It doesn't have a floor. Okay, let's do this way as math. What? Huh, interesting. So maybe it's on here. Oh, there you go. Okay. So now we basically floor it, or we could also round it. It doesn't matter. It's not that important. There you go. So we round it. So now we have the current index. Then we know what the current sprite is. And so every time we update, we just increase the clock and so on, right? And now we need one more thing. So basically, if current index is greater than the frame count, where do we have that? So SpriteSheet of frames count. Right, then we actually need to set this. So if we could also say it's like the math.max, the min of that, or the SpriteSheet frames count. So since this is like a getter, we don't want to invoke it every time, so we actually store it here. Frames count, and we'll just assign it here, and we say frames count. Is that it's not a constant or something? Okay. And so we can just say frames count here. So we have the available. So we don't invoke that getter all the time. Its format is a little different. Well, it doesn't like it. Okay, that's odd. There's something else going on. But we'll figure that out. So basically, it needs to be, it cannot be greater than the frames count minus 1, right? So, okay. So that's that. So now, well, actually, you know what? This is not entirely. Yeah, let's just not fix it here, right? So actually what we're going to do is we're going to have a bool here done, and that one will tell us if the current index is basically greater or equal the frames count, and we're not looping, right? but basically, if we are looping, if loop and the current index is greater or equal to frames count, then we say current index equals 0. So we reset the current index, right? So that's the SpriteSheet animation. And you can see that it doesn't really render anything, it doesn't really animate anything, it just basically keeps track of things to tell us what sprite we need to render, right? So now if we go here, what we can do is we need an update method to call the. Okay, so first of all, how does the SpriteSheet animation? So we need to actually create a SpriteSheet animation from this. Right. Okay. So we create the sprite, but we create the from that we create a SpriteSheet animation. Okay. And it wants the duration as well. So we're going to say for now it's going to be 200 milliseconds, but obviously we can change that. We may want to pass it in actually. So now the SpriteSheet animation, we just actually get the sprite, right? And then we render that. Okay, that's fine. And now though we need in the update method, we will actually update our animation. Update DT. And so now the animation will go forward. Now the thing is though that we need to actually have it done as well, right? You communicate it somehow, and that basically is the same as our SpriteSheet animation done. Now, so if you're done, we don't want to render anymore, right? So if done, return. And actually, we should probably do that as well here. If done, return. So we have no room for error there. We will do it here as well. And then also definitely we shouldn't render anything if we're done, right? Because that's just not going to go well. Because we're going to access a sprite here that's not happy. So actually, I think we're fine. We can update. It's just going to return. So. So now that's the animation. So now if we render, so for now we're actually going to loop, so we can see how what it would look like if it would just loop all the time. So if we do this, we see nothing. Okay, that's interesting. Oh, because we're not updating, right? So we need to actually. Whoever's create a thrust sprite, the player actually needs to it needs to update the thrust sprite, right? Interesting enough, we only if well, it keeps updating it, and it should actually always render it as well, because we should actually reset it if it so this actually needs to happen here if the model, right, if model dot applied thrust, then actually the thrust sprite needs to be reset. Okay, and we don't have that yet. So we create this method real quick. And so what does reset do, right? Well, it will reset the animation, right? So we need to SpriteSheet animation to reset. And we create that method as well. And all we have to do here is that the current index is 0. And most likely the clock, we just reset the clock as well. Clock is also 0. And let's see what else. So basically, this will only get set once in frames count. So these things don't change, right? And actually, they could be final. Let's see. Only static members can be accessed, but well, what if I do it this way then? Oh, maybe it's because it's not final. Okay. But basically, this should. So if I move this, we're getting this twice. I don't like this too much, but I think we'll live. Okay. So now we have the ones that don't change final, and the only ones that do change will reset. Okay. So that's what the model does, ThrustSprite does. It resets it, which means when you render it actually shows something. It's not going to be done. So that way we actually, we never have to remove the ThrustSprite, right? We just can keep it around. So let's see what happens now. If I run it, okay, we don't see, okay, here we go. Okay, so it looks really weird. That's pretty obvious. It's because it's getting reset all the time. So we actually don't want to reset it all the time. So actually, now comes the interesting thing. Actually here, only when we actually increase velocity should we set the applied thrust through, right? Otherwise, we should set it to false. So actually we set it to false at the top of everything. Right. Set it to false here. Okay. Let's do this way. So we set the dot applied thrust equals false, and only when we actually apply thrust will the thrust bed reset. Then we'll keep updating every time, and so then it should render fine. Got like 5 minutes left here. So now if I go to the where we create the models, we'll set it to false because we didn't apply thrust yet. And now, okay, so now we actually be fine. So we got some weird problems here going on. Maybe we get some error and I'm not aware of it. There you go. So something's going on. Method greater equal was called on null. So something is null. Greater equal frames count. Frames count is set. Sprite's length. That should be fine. Frame ms is duration ms. But the current index, yes, we need to actually set that. So basically what we do in the constructor, we just reset when we get created. All right, now we should be in a much better place. Okay, now we didn't get any of these errors. Okay, we can now do it. And we get a thrust. Very nice. So now every time we accelerate, we get a thrust, which takes about 200 milliseconds. What I'll just do now, I'll clean this up a little bit and I'll make the thrust like the timing of the thrust, make that something of the game props and pass it in to the thrust. The duration here we need to that needs to be a required animation duration ms, and so animation duration s. So we have loop true, which is kind of funny. It's kind of interesting that the looping didn't work. Well, if we ever have a looping animation, we'll fix it. For now, I'm happy with the way this worked. Obviously, we need to make sure now that this still works, but let's first go here. Right, we need to basically, so what we do is final double Rust duration but actually we don't need this to be even a thing, right? And then we say here so this is how long a thrust lasts, but maybe we'll just rename it to be more clear. Thrust animation duration ms. Then when we create the player, we have to pass it in. So we do is we go here and we'll declare that correctly. So we say player thrust animation duration, and we set 200. Okay. So we say thrust animation duration game props thrust, and of course you could say let's make this milliseconds, even though in our game everything is milliseconds. So, and you could argue that maybe what's happening now? You could argue that this should actually be part of the thrust sprite, but it's kind of nice to have everything in one place. So if you want to kind of play with these values, you can see the relationship and everything, and it actually works out really nicely. You can see all the assets you have in one place and all these things. So I kind of like it that way. So let's see. Okay, we have our player, we have the thrust, perfect. Now we just got to make sure that this still works in the browser, and then we can publish this before we come back. Okay, let's run this one, and we're just gonna check this in already. Player adding thrust animation, but actually we already were in the middle of it, so we're just completing it, right? And so now you can see that in the model. In the player model, we also don't keep track of any. In the player model, we don't keep track of the state of the thrust. We just say that the player applied thrust, and that should be enough. And so then basically the server can send the other players information that one player. Okay, so now here we can see that in the browser, it looks a little, for lack of a better word, kind of shitty. So it doesn't look quite as great as on desktop, but I mean it's good enough, right? It's good enough, and it still works. So okay, so we can publish that, and so what I wanted to say is like, so we applied thrust, that model gets sent to the server. The server can then tell the other players, hey, this player applied thrust, and then they will apply the animation, right? And the animation will just time it by itself, and we don't have to keep track of the animation. You can kind of see that here also. The player doesn't care. The player just basically if it applies that, reset this guy, and now I don't care anymore. I'm just going to update it anyways, and that's it. And you might actually say, why don't you just update it before, which probably would make sense. Right, so but it doesn't matter, because if it's fine. we update it, and we always call render in it, right? And we don't even know that most times it will just return, but that's fine. We don't want the player to be responsible for the animation itself. The animation takes care of itself. That's the whole idea here, that we don't have to worry about that, and it's not part of our game state. It's just a visual kind of thing, right? Okay, so now I'm going to Flutter build. So actually, so you can see this better, maybe Flutter build web. We built for the web. Okay, maybe I just need to say web by itself. All right. And so and in the meantime, I guess I could already tag it. Tag episode 8 and push. All right, and then basically I copy the build web start to the little GitHub pages. Then I go there and push that as well. Okay, so now we got that, and so now if you go to our page, we should have the updated version. So it might take a while, so we don't see it right now. That's fine. So this is the value old version. We have to force refresh. There's still no thrust, but it'll come. It'll come in. The main idea is that it works in the browser. It doesn't look quite as great as in the Mac OS directly, and probably in the phones it will look quite as good as in the Mac, hopefully. We'll check that out. But for now, I will say thank you for watching. Yes, so I just want to point out again this is what we're working on. GitHub.com /Lawrence/Batufo. If you want to know more, follow me on Twitter. I am /Lawrence on Twitter as well. So if you go to twitter.com, and then slash. It's kind of hard to see sometimes. Some still depend on looking at my keyboard. Not a good thing, but and the microphone is just in the way. So here we go, /Lawrence. You can follow me there, and I'm tweeting every time I do an episode or finish an episode, so you can stay in touch there. That's pretty much it. Thank you very much for watching. In about an hour, a little more than an hour, we'll continue. At 7 o'clock here is 9 o'clock Eastern.